Okay, you are welcome back to the part 2 of the video. So now we are going to do the analysis and then the design. So before we start, I am going to change this view back to um, the normal, which is the standard. So change back to standard so I can see just line. So apply and then okay. So we are going to see just line. So what I'm going to do right now is we have to determine the load. So I want to add the dead load. So now the question should be, what should be the dead load of this element? You understand? What should be the dead load of this element? So how do you calculate the dead load? You just need to know you can come to define, check the property. We are working with this property, right? So come to modify or show material. So this is exactly what I want to look at, the weight of the material. You can see the weight of steel is what? 76.9729, which is about 77 kilonewton per meter cube. So that is the weight, that is the unit weight of steel. Okay, so if that is the unit weight of steel, and then what is the section? Let's just check the section. These are the sections we used. I use 120 by 120 by 10. There is 100 by 100 by 10. So I can just use the highest. Let's use 120 by 120 by 10. So if that is the load, let's pick the calculator. So this is how we are going to load it. I am going to load the joint at where you have the column here. I will load it with the dead load of the column, and I will also load every part of this frame. So for the column, the dimension of the column is 0.23 multiplied by 0.23 multiplied by the height, which is 2.1, multiplied by the self weight of steel, which is 77. So that will be giving me about 9. Let me just say this is 9 kilonewton. So at every joint there, I'll be loading it 9 kilonewton. And for the frame of the roof, so I will load it. That's 0.12, that's 120 mm, then multiplied by the thickness, which is 10 mm, 0.01, multiplied by the unit weight, that's 77. So that is about 0.0924 kilonewton per meter. This is not in kilonewton, this is kilonewton per meter. That is a UDL. So I'm going to load it UDL. So I can exaggerate this to be 1 kilonewton per meter square as well. Alright, so that's good enough. So right now let me load all of this. So pick this joint, pick this joint, pick this joint, pick this joint. I mean the joint where you have the columns. So pick this joint, pick this joint. Then you come to assign. So go to joint load, forces. So just leave it in global. Then the force is in Z direction, right? Z direction. So that will be it is coming downward, so I should put a negative value. So that's minus 9 kilonewton. Let me just exaggerate it to be 10. Minus 10 kilonewton. Say apply. Okay, so I believe you can see them here. Let's zoom in. You can see it here. You can see that downward load. You can see the downward load. Yeah. Okay, so those are the load on the column. Okay, so close this. Let me zoom in a bit backward. So now we've loaded the column. So now we just need to load the roof truss. So as I said, I'm going to load it as a frame. Okay, so now that we have loaded the column, so we need to load the roof also. So as I said, we are going to load it as a frame. So I'll select all of the roof, something like this. Then you come to assign. So we are not assigning joint load, we are going to assign frame load. So you assign a distributed load. So and then just leave it in gravity, and then it is a force, right? So leave it in global, so it will definitely do the needful. So leave it in gravity, and then the uniform load. Now the uniform load will be um 1, right? So let me increase it. No, let me just leave it in 1 kilonewton per meter square. Then say apply. Okay, so if you look at it now, it has applied the load as UDL. You can see everywhere as UDL on the frame. So you don't need to put minus here, it will automatically recognize it. So it's going to apply it like that in the axis. So you just click OK. So we are done. There's another thing you can do. You can define your load case, a load combination. So this is load pattern. So come to load combination, then add new combo. We have dead load, right? So I'm going to factor it with 1.4. So you say add, so you say OK. Yes, so that's the combo. So say OK. So you can now analyze, say run analysis. So that is for this. Run this. I want to run just the linear. For this one, the modal, you can leave it as do not run. I don't want to run the modal, I just want to run the linear analysis. So you can click on run now. So you can check here, it will tell you the progress. Okay, so it is done with the analysis. So, and this is how it will deform. This is how the deformed shape will look like. This is not how it will be exactly. It's just an exaggerated, So you can check the animation. You can see the bottom here. You can see start animation. Click on it. It will animate it for you. Yes, and it will play a bit of music. So this is how the animation will look like. And so it is interesting. It is an exaggeration, as I said. This is not how it will look like. So you can stop the animation. Okay. So now that we are done with the analysis, so you can come to display, then come to show forces and stress. You can come here, show forces and stress. Then come to frame or cable tendons. So you will select the particular one you are looking for. So force, right? So let's look at the axial force. So you can just say apply. So you are going to see the axial force diagram. So if you are interested in the moment, moment 33, so the same way. Okay, but you can see it is just it is just showing the diagram. It's not showing you the figure. That's because you are only seeing the diagram. If you want to show the values, click on this. There is a apply. All right. So the value will come up, so you can see the value is there now. So you can zoom in to see the value. Okay, now that we are done with the analysis, we shall proceed to the design. So you can either come here and then you click on the steel frame. So you can come to this tab, or you just click on this is for steel, this is for concrete. So you can click this drop down, then you come here directly. So here you can make some changes that you want to make. For example, the design code is very important. You can change it. This is Indian, but unfortunately I can't change mine. I only have Indian. So you can change that. And then also some things, another thing you can change is the seismic code. You can ignore it, you can click yes, but I decide to leave it no. So when you see a blue color, this is what it means. That is the default value. If you see black, it means okay, it is not a default value. And when you have red, it means that that value has been changed during the current session. When you are working, it means you've changed it. Okay, so I just want to leave it like this. So just click on OK. So I'll proceed to the design properly now. So you just click on start design or check of structures. So it's going to design in. So you can check here, say checking steel frames, and here it is loading. You can see it's around here, it is loading. So when it is done, you say it. Okay, so I have almost everything in blue, which tells us that everything passed except the main steel. I could have changed it from the beginning. I actually made a mistake. I wanted to use 120 by 120 by 12, but I used 120 by 120 by 10. So it's like this thickness is not, you can see the thickness is not good enough. So what you will just do is, you can see we only have this six, 1 2 3 4 5 6, that is all of the main steel. So you can come here and then say verify all member that passed. So it's going to tell us that we have 49 steel frames that are actually failed. That is the frame including of this. So it has selected them. You can see they've been selected. They've been selected. So what you can do here, you can just unlock your model. Then you come to define, and then you go to section properties, frame model. So talking about, I think this is the, yeah, this particular one. So you can just say you want to modify or show property, but unfortunately you'll not be able to change it here because we imported the property. So, and I told you that when you import the property you won't be able to change it, unlike this one that we did import. So you can see for this one you can change this one, but right now you won't be able to change it because you've not unlocked your design. So you have to come here, you have to unlock the model. So your design and everything will cancel. So let me click on it, you can see it will tell me that my analysis results will be deleted. So you click on OK, then it will delete it. Then you can change this section, you increase the section so that you can pass the design. So better still, what you can do is, instead of importing the material, you can just add new, and you enter 120 by 120 by 10. So even at the end of the day you will still be able to change it, but when you import you'll not be able to change the dimension. And this leads to the end of the design of a steel structural pergola using SAP 2000. If you like this video, ensure you like and subscribe to this YouTube channel, and then you can click on the bell icon so that you receive notification as soon as I post new videos. And if there's any question you need to ask me, you can put it in the comment section. I will definitely reply to it as soon as I see it. Thanks for watching.